In this video, we're going to find the difference quotient of a function. The difference quotient deals with slope. You know, y minus y over x minus x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And in the sketch right here, this could be y sub 2, y sub 1, x sub 2, x sub 1. This equation, the difference quotient, stems from slope. So it deals with slope. But it doesn't have to be just slope of a straight line, it can be slope of a curve. The slope of a straight line going through a curve. This black line, we can call it a secant because it's intersecting this curve in 2 points here. This will find the slope of the secant for any value of h, where h is the distance between these 2 points. And this is the foundation for calculus, so this is actually really important. Because in calculus, we do find slopes of curves. So I'm going to erase this picture. Now you know it deals with slope. And we're going to do 2 problems. We're going to find the difference quotient for 2 functions. My first function will be f of x equal to 2x plus 3, which actually is a straight line function. And we're going to find the difference quotient for that function. So we'll set this thing up. Oh, and by the way, before we start, this equation can be simplified. X plus h minus x. Yeah, x minus x is 0. So this denominator here is just h. So let's use that. We're going to find the difference quotient for f of x equal to 2x plus 3. Okay, that's the hard part. Let's start with the easy parts. I'm just going to draw a big fraction here. Going across. I see there's a minus right here. I'll put a minus. I see there's an h in the denominator. I'll put an h. And I'm just going to substitute this function right here. Make sure I put parentheses around it though, because we have to subtract the quantity 2x plus 3. Right? Distributive property. We're going to have to distribute that minus 2x and a 3. Alright, now the hard part. It's not so hard. We're going to find f of x plus h. So what is f of x plus h? I'm going to go right underneath this. All we're going to do is substitute for x and x plus h. So if f of x is 2x plus 3, well then, f of x plus h is 2 times parentheses x plus h plus 3. Please note, everyone, f of x plus h is just 2 times parentheses x plus h plus 3. I just substitute for that x, this x plus h. So I'm going to place all this right here. This 2 times parentheses x plus h plus 3. Now all we have to do is simplify this. Distributive property, collect like terms. So when we distribute this, we get 2x plus 2h plus 3 minus 2x minus 3 all over h. Alright, combine like terms. 2x minus 2x. Those go away. 3 minus 3. Those go away. We're left with just 2h over h. And yes, we can cancel those h's. This final answer is 2. Now do you see the connection? I said this dealt with slope. And if you have knowledge of slopes of straight lines, the slope of this straight line is 2. And look at the answer, 2. Okay? But this is a powerful, powerful equation. We don't have to just do this with straight lines, we can do this with curves. So my second example is going to be a curve. I'm going to take a parabola. So I'm going to erase this. Just make sure you're good to go with this hard part, right? That's not so hard. F of x plus h. You're just going to remove that x and substitute an x plus h with the parentheses. Okay? So my second example. Let's do f of x equal to x squared plus 2x minus 5. So we're going to find a difference quotient for that. It's not going to be hard. It's not going to be hard, but it will be more work than the last problem. just because we have two x's in this equation, in this portion right here, in this polynomial. All right, let's start out. I'm going to make a big fraction bar. Here we go. Start with the easy part. Put the minus there. All right, put my minus. I'm going to put this function right there with the parentheses, so I can distribute that minus x squared plus 2x minus 5, since we have to subtract that quantity. I'll put the h in the denominator. Okay, here we go. What is that? X plus h. Take it slow. Let's go right underneath this. Substitute for every x an x plus h. All right. Here we go. Oh, there's an x. Substitute an x plus h. Now notice there's a squared right there, so that squared's going to be here. This is actually x plus h squared. The quantity x plus h squared. See that x plus h? Let's just substitute for that x. Plus 2, oh, there's another x. Get out the blue marker, substitute parentheses, x plus h. And then there's a minus 5. Not so bad. Not so bad, a little bit longer than the last problem. I'm going to put all that right here. So we have parentheses x plus h squared plus 2 times parentheses x plus h minus 5. Everyone, that's not x squared plus h squared. You have to do the distributive property, aka FOIL. We have to FOIL that thing out. So you have an x plus h times an x plus h. Right there. Let me just point an arrow here. See that x plus h squared? That's x plus h times x plus h. And when you do FOIL, first, outers, inners, last, you get x squared for the first two terms, plus xh, plus right here, xh is the outers, the inner is another xh, plus h squared. Yeah, that wasn't so easy. Not so bad though. You have like terms right there. So this is going to be x squared plus 2xh plus h squared. All this will be the quantity x plus h squared. So I want to show that, and I'll erase this. I'm going to put this in our next fraction bar when we rewrite this. X squared plus 2xh plus h squared. Okay. Here we go. And then we're just going to collect like terms, right? Distributive property. Simplify this expression. And this fraction bar is getting long. All right. X squared plus 2xh plus h squared. That's that. This is plus 2x. Distribute that 2. Plus 2h minus 5 minus x squared minus 2x, and a negative times a negative is a positive, you get plus 5. And we're just going to combine like terms. A helpful hint, in this numerator, anything without an h connected to it should somehow go away. Look, there's an x squared. There's a minus x squared. Bye-bye. See, it didn't have an h with it. Oh, that has an h connected to it. See, that doesn't go away right now. H squared it has an h in it, doesn't go away. 2x is a minus 2x. Knock them out. You got a minus 5 and you got a plus 5. Do you notice everything without an h connected to it in that numerator went away? That helps. That helps. So now I'm left with 2xh plus h squared plus 2h. All over that h. But it's getting a lot better. This is prettier. The last thing we have to do, notice everything has an h. We're going to factor out an h so we can cancel it. So I'm just going to put a little equal sign here, factor out an h. We have 2x plus h plus 2. All over that h, and yes, everyone, you can now cancel. Final answer. The difference quotient for this function, x squared plus 2x minus 5, is 2x plus h plus 2. It may seem like this has no connection in real life, but it does. All right, the foundation for calculus. We deal with that h in calculus, but this involves slope. It involves slope and slope of that curve. It's a parabola like this. And you can find a slope at any point on that curve using this concept. And that's it.